Recapping from Lesson 1, there are three basic parts to the camera for photography. They are light, lens, and recording media. These three things all work together. That is, if you adjust one, it impacts the others, and over the next few lessons, you will come to better understand this concept. Some form of light must be present for a photo to be made, and that's just what this lesson is about. The light then passes through some sort of a lens, and then the light is captured by some sort of a recording media. What we call light is just the visible part of the electromagnetic spectrum. Visible light is just a very, very, very narrow part of the entire spectrum that ranges from what we call radio waves to gamma rays. Radio waves are really long waves, with each one being longer than a soccer field, and gamma rays are shorter than the smallest part of an atom. The visible part of the electromagnetic spectrum is a very, very, very small part, but all of the electromagnetic spectrum is light. It is just the light that we can't see. We can detect light that we cannot see with our eyes. We can detect it with our bodies. That is, you can feel heat, and that's just infrared light. And you can get sunburned by ultraviolet light. We can build detectors in cameras that allow us to photograph light that we cannot see. Perhaps you've seen an X-ray. This is just a photograph that uses light that is not visible to our eyes. You can easily see how light can penetrate through things which we can't normally see. Here, you see light from a flashlight penetrating a sheet of paper. The sheet of paper does not stop all of the photons. It would take several sheets of paper to stop enough photons that our eyes would not be able to detect the light any longer. This is a good example of how the X-ray photos are made. Some of the X-ray photons get through the softer tissue of the body, and some do not. Perhaps you have seen photos that were taken using radio waves, or perhaps you have seen photos that were taken using ultraviolet light. Or perhaps you have seen photographs that were taken with heat waves or infrared. Some animals can see in infrared and ultraviolet, so they can see colors that you can't even imagine.
Human eyes can detect 3 color wavelengths. The mantis shrimp can detect 5,400 of them. Just kidding. They can detect 12, 9 more than we can. But it's less impressive now, isn't it? Just 9, whatever. Imagine a color that you can't even imagine. Now do that 9 more times.
Flowers sure look pretty to us, but bees see them in a completely different light. Literally. Not only do they see the world through these compound eyes made of thousands of individual pixels, they see a world bathed in ultraviolet, way beyond what our eyes can see. We see this, and they see this. See, special pigments absorb the UV light, and they paint this big bullseye in the center of the flower, guiding the bee to the tasty nectar, and of course that sweet, sweet pollination.
Many snakes have what's essentially a built-in thermal imaging camera. They can use infrared light to track down even the quietest prey in the dark, including us. But the night vision of some insects is even better. For cockroaches to navigate, their cells require less than 1 photon per second, and researchers still haven't figured out how they do it.
These other forms of light of the electromagnetic spectrum do not have names for the colors since we can't see them. In these photographs, we have to assign colors that we understand. That is, we assign colors that we call false colors. Color is something that exists inside our head where we see. No one sees the colors that you see. Sure, you look at something and say, "That's red," and another person can look at the same thing and say, "Yeah, that's red." But the red that one person sees is different from the red that another person sees, and still there are many people whom we call colorblind, who only see the color red as a shade of gray. There is much more that we could say about color. colors that we see and colors that we can't see, but for the moment we will shift to another aspect of light. That is, another aspect of light that is different than color is the amount of light. Though there are scientific terms and measurements, the old standard is the foot candle, and it is the foundation for other ways of measuring light. 1 foot candle, called a lumen, is the amount of light that one candle can produce from 1 foot away, spread over 1 square foot. You can see for yourself how much this is by setting one candle about a foot away from the wall and turning out all of the lights, and looking at how much light falls on the wall in an area that is slightly larger than a sheet of notebook paper. Now imagine what would happen to the amount of light if you were to set another candle right beside the first. Another thing that you will notice about the candle light is its color. We will call that a warm color. Candlelight has a temperature of about 1,000 to 2,000 degrees on the Kelvin temperature scale, while the temperature of direct sunlight is between 5,000 and 6,000 Kelvin. Different lighting temperatures create different moods in photography, and we will explore those in a later lesson. Another aspect of light is the amount of light. Just like you can produce 1 lumen or foot candle with 1 candle, you can put 2 candles close together, and there you can produce 2 lumens. Then, when you add more candles, you add more light. The temperature of the light does not change, but the amount of light changes. The way that the amount of light lessens as it spreads out is important too, and it is called the inverse square law. It is not all that difficult, but will be explored on its own in another lesson. It is not as simple as the amount of light lessens by 1/2 when the distance is doubled. For about $20, you can purchase a flashlight from Walmart that produces 1 million candles of light power, but the color of the light is not the warm glow that you get from a single candle, but about 6,000 degrees Kelvin, or about what you would get from the sun. To prove to yourself that there is light that you can't see, take the remote controller for your television and look into the end of it. The end that you normally point at the television. You should see what looks like a small lens. Press a button and you will see no light. Point the remote at the television and use it to change the channel or the volume. You do this to verify that it's working. Now take the same remote, turn on the camera on your cell phone, and point the remote into the camera lens. Press the volume up or down button, and you should see light coming out of the end of the remote. Your cell phone camera sees or detects lights that you can't see. Another aspect about light and writing with it is the hardness and softness of the light and its shadows. These too will be explored in greater detail in a future lesson. This concludes the intro lesson about light, though there is much more to be covered, and we will in future lessons. You should be able to answer all of the following questions. Are radio waves just light that humans can't see? Are X-rays just light that humans can't see? If infrared waves are just light waves that you can't see, and if radio waves are just light waves that you can't see, does that mean that you, in a weird sort of way, are like a light bulb or a radio transmitter? What light waves are there that humans can't see but can easily detect? How is the color of light measured? How is the amount or volume of light measured? How might light be important to photography? What piqued your interest that makes you want to go off and learn more on your own rather than to wait for the next lesson?